So in this video, I want to talk about function parameters, scope, and pointers, and how those ideas all interact with one another. So this is basically going to be pulling together a few things we've been talking about, and introducing some terminology, and going through a couple of examples about basically different ways that we can take data and bring it through functions. All right, so to start with, functions and parameter passing. So functions, right, we've been using these. Basically, right, the overall idea is we're in C. C is not an object-oriented language. Instead, it's what is called an imperative language. And basically, all we have is a bunch of different functions, right? People maybe call them other things, procedures, subroutines. In Java, they call them methods. Basically, little blocks of code that all have their own names and then have some parameters associated with them or some arguments associated with them. Basically, data that function is supposed to act on, and at the end of the day, you get some result back out. The idea of a function, right, is that we have some level of abstraction, right? We have some piece of code, right, and it could be any length. Maybe it's just one line, maybe it's a ton of lines. And at the end of the day, all we have is basically a name for it, right? It's one unit, and data goes in and data comes out. And as we need to, right, we can maybe take this one bit of named code and we can reuse it in a bunch of places, right? We can call it here, we can call it there. Everything kind of is reusable. And ultimately, right, anytime we write a C program, it's just going to be a set of functions, right? And those functions are ultimately going to call other functions, right? They're basically going to all be composed together to form an overall program. Now, in general, right, if we have a function, you can communicate with the rest of the program in one of two ways. One way, right, is by changing global or static variables, which is generally a bad idea, right? It makes our programs harder to debug. And the second way, right, is via parameters or return values, right? And we've been using that already. But now when we kind of throw pointers in the mix, things are a little bit more complicated, or rather I should say we get a little bit more flexibility. All right, so a little bit of terminology there at the end. Formal parameters. So the idea is that when I write a function signature, so I have int test and then open bracket int a close bracket, a in that context is a formal parameter, right? It's the name of the parameter in terms of the function signature, right? Not in terms of me executing it all, but what did I write in the IDE or the text editor, right? As the name of a parameter. We'll call that the formal parameter name. The second thing I have is a actual parameter. So once that program actually runs as an execution and it goes to call that function, well then there's going to be some value that's being fed into that function for the argument. And we'll call that the actual parameter. What is the actual value being given to the function, right? Or what is the argument? So there's kind of two levels of abstraction here, right? Before compiling or before executing, it's a formal parameter, right? It doesn't have a value behind the scenes. Once it runs as an actual parameter, it does have a value associated with it. Types of parameter passing. Well, in general, we haven't had to think about this. Maybe in other programming languages, we didn't really have a choice. The choice is automatically made for us. But in C, because of pointers, we're actually going to have some different choices. So the general thing is this idea of pass by value. So let's say I have a function and it has an argument, just int a. Now, that's a pass by value argument. When I go and actually run that function, what's going to happen is that the outside world is going to say call my function. Let me maybe write a function real quick here. Something called test, and test takes in int a. This is just kind of our sample function here. Int a. I'm just writing this all in uppercase because it'll be easier and because I like uppercase. So test, and this is a void type just because. Void test int a. Right, a is a formal parameter, and this here is this will be a pass by value argument. The idea being is that when the outside world calls test, right, they go test of 5. That value 5, right, is going to be the actual argument or the actual parameter, aka the argument, and that value 5 will basically take the place of a, right? So it's no longer just a letter, right? In terms of the body of the code for test, it's actually going to be the number 5. So in that case, what's happening, right, is I call test, so I have to create a new stack frame, and in that new stack frame, I'm basically going to have memory allocated for int a, and then the value of a from the outside world is going to be passed into or copied into that area of the stack frame, right? So we have our own int a, right? Even though that value has to be coming from the outside world somewhere, for us, we're going to have our own local copy on the stack frame. And then once the function exits out, right, once it returns, then that stack frame will be popped off, and the memory it was allocated to store the value of a will just automatically disappear, right? It'll go away. So this is how most of the code you've written has been working. Everything has been passed by value, right? We call the function, makes a copy of the arguments into the call stack for kind of local usage, and then once you're done, it throws it out. This is what we've been doing so far. The big advantage of this is no side effects. So basically, we get a copy of that argument to ourselves. There's no chance of me doing anything strange inside test that changes the outside world. So inside test, if I do something like a equal 15, that's not going to change whatever is outside, right? Whatever variable or value was fed into test as an actual parameter, that thing will be left alone. So there's kind of a little bit of compartmentalization going on there. The problem is, right, on the flip side is I can't change the outside world. So if I wanted to, get data back out of test, I can't really do that because test has everything as just a copy of what it started life as, right, as what it is outside. So that's a disadvantage. The second way we can think about passing around parameters is by doing pass by address. So pass by address is basically saying, okay, instead of passing around that actual piece of data, like that int a, I'll pass around a pointer to it. So all of a sudden my parameters, right, look like pointer types because they're basically giving me a way to get outside, right? I have an indirect way to access some piece of data. So instead of having a copy of the contents of a, what my function would really have is the address of a. Now that address, right, basically is going to be a pointer. Inside of the stack frame, right, I'll have a variable that's effectively something like int star, and then in there will be stored an address, and the address will point at wherever a is coming from. But what I'll have, right, is that address that lets me see basically outside of this function. Instead of it just being this local bit of data, right, having a copy of a that's locally in the stack frame, instead of that, what I have is I have this address to somewhere outside. So then if I do something like, let's say star a equal 10, what happens is, oh, you're not changing the value in the stack frame, right? The value of the stack frame is just the address of where a came from. Instead, you're going to the outside world, and whatever value was fed in for a, that's what you'll be impacting, right? So if I call test on a variable call, b or something, so if I call test on a variable call, for example, b, well, then I'm going to actually update the value of b in the outside world because it's a pointer, right? It's letting me see something outside. So this is actually very useful. Basically, we're being allowed to change stuff or return more values out of the function than we would normally be able to, right? Normally, we're limited to just returning one thing, which is basically the return value would be the only way to get something out of the function. But when we pass things by address, pass things by reference, then we're basically being given ways, right, to look outside of this function and change things. Okay, so let's take a look at some examples for both pass by value and pass by address. The first example here is for pass by value. So let's take a look first at the main function. Basically, what this is composed of, right, is I have my globals over here, my functions over here, and my main over here. So take a look at my main. Let's just read through this and try tracing this code. So main runs, right? So we can imagine we have a new stack frame created for main. And inside there's going to be space for j, right? J is a local variable inside of main. And so j initially has the value 2 being set into it. And then we run function I and j. So function is kind of an arbitrary thing. It's just going to do some random manipulations so we can see what happens. And it takes those two arguments. So I have my formal arguments here, right? M and n. And then over here, right, when I actually call it in my main method, right, when I give it the actual parameters, right, the arguments, then I'm using basically the values of I and j. And so as that function is being called, right, I need to go and create a new stack frame for it. What happens is the system is going to look up and see, okay, what is the value of these two things, I and j? I is a global, it's the value 1. And then j, well, j is over here, j is value 2. So that m and n, right, effectively disappear. And instead I just have that entry in the stack frame where that m value, right, is 1, n value is 2. I shouldn't really say they disappear. Really what's happening, right, is I'm making a copy. So I and j disappear. Instead, what we're doing is we're making a copy of the value of the data that was stored there and then referring to that as m and n within this function. So tracing through this code, the first thing we have is a print statement that basically prints out the contents of I, m, and n. Well, I is a global variable, so we can imagine, we look over here, it's going to be a 1. Then over here, right, m is linked to this thing over here, that's going to be a 1. N is linked to this thing over here, that's going to be a 2. So we should see 1, 1, 2. And if we look at our output over here, that's exactly what we see, 1, 1, 2. Okay, next line. Now I go I equal 5, m equal 3, n equal 4. So I is a global, so that changes outside, right? Everybody sees that change. And then m and n, right, we're saying 3 and 4, that change only happens within this function. Because we're doing this call by value, right? That m and n only exist within this function, they don't exist in the outside world. So let's go ahead and do I will see the impact of that in a second. I'll go ahead and do another print statement here. We'll go I, m, and n. And we can see here, right, our I is updated to 5, and then our m and our n are updated to 3 and 4. So we print out those exact values we set in there. Now at that point, the function exits out. right? And so over here back in main, right, our function is done, and then we have this print statement again to print out the I, j values. Now over here, notice that when we do this, we're printing out I as in 5, and then j as in 2. So I is a global, so there's basically just one variable out there, right? There was never any copies made of that. That variable is basically going to reflect what happened inside the call to func, right? That was set to 5, so we display 5 here. Now over for j on the other hand, it was a local variable inside of main, and even though we passed it to func, and func actually changed basically the value of that 2 to a 4, well, that only happened within the scope of that function. It's call by value. So in the main, that j is untouched, is still the value of 2, and so when we go to print it out, we'll get back the number 2. So that's kind of an example of us doing call by value for everything. Basically, we have copies of everything being made as we make different function calls, so anytime we change values inside of it, that change will just stay inside of that function.